look at it. Oh, sorry about that, Wyatt. But I'm glad you are here. Yeah. So what I wanted to talk to you about was, as I was looking at the chapter one and, getting ready to kind of put that exam together, I actually realized that in the grand scheme of things, we haven't actually done a lot of concept talking, right? We're just introducing trigonometric functions and we've just kind of built it up with the right triangle trigonometry. So I kind of wanted to get everybody's view on this. What do you guys think about maybe combining chapters 1 and 2 into one single exam instead of doing them separately? Because, that's kind of how I had started out. If you look at the course syllabus, I had chapter 1 exam separate and then chapter 2 exam separate, and same thing with chapters 3 and 4. But like I said, when I started kind of looking at the questions, I was like, this is not really a lot of a lot of topics that we have talked about. So I'm kind of wanting to combine chapters 1 and 2, but I do want to get your input. So you can put it in chat, and I'm already seeing a lot of feedback coming in, or you can unmute yourself and tell me what you feel about it.
So if we combine those, then the exam obviously is pushed out to a later date, correct?
That will be correct, Gabriel, because
And
we're finishing chapter 1 today, but we'll finish chapter 2 and then do a combined exam between 1 and 2.
and would that date be based on the chapter 2 exam when we were going to take that on the syllabus, the dates?
Um, I mean, that would be the goal. Would it be terribly awful if we finish chapter 2 before that due date? And if we decide to take the exam before that? Yes, all right. So let me get into chat because I have not looked at it. So Mickey, you said if you have more time, that's fine. Mark, you like the idea. I said Buckles, you wouldn't mind this. You have enough time to complete the exam during class hours. Yeah, and we're going to definitely keep it for class hours. Brayden, you said okay, sounds good. Anna, sounds good. I agree. Josh, okay. Cameron, sounds good. All right. You had a question, Mav. Does chapter 2 rely on chapter 1? Yes. So we are always building up on concepts on Mav. So yeah, we will be, whatever we're learning in chapter 1 is what will lead into with chapter 2. Right. No, I agree. If they were completely different concepts, then it would be like two different things. But no, you're building up on them. Isaac Luhan, you said, uh, not necessarily that there would be twice as many questions, but I kind of feel like it would actually be, some of the questions from chapter 1 will automatically be part of chapter 2. So I may not have to test you separately because I'm like, oh, I know you're using this concept already on the questions in chapter 2. So you wouldn't have to do like two separate questions on the same concept because I will still be able to test you on that. Okay, Mav, you said okay. So the benefit of combining the two would be, because my concern is that the chapter 1 exam is not going to be enough to justify taking up a whole class period to do a chapter exam, because when I do the exams, I give you the entire class time. And because we have really just kind of touched the basic foundation of chapter 1, I just feel like, I'll be giving you an exam which may barely be 30 minutes long, but then I still have to give you the entire class time to take the exam. And I would rather us do another chapter, put it together and give you at least like, a 15-minute to an hour long exam, which justifies using the whole class time. And like I said, we haven't done enough material coverage to be able to do like, a one whole exam. This just kind of feels like, like I said, a shorter version of that. And that's kind of why I wanted to get your input on what are you guys feeling about that. I mean, my goal is not to overwhelm you, and I'm not going to, like Isaac had asked, double the number of questions. The questions will still stay in that 1 hour time frame of a testing time, right? So I'm not going to try and like give you double the work, for one exam. We're still going to try and keep it at a reasonable amount. So yes, Isaac Buckles asked, does that mean we will not be doing the exam this Wednesday? And that is exactly right, because then we will wait to finish chapter 2 and then pick a new date for the combined chapter 1 and chapter 2 exam. So Phoenix, you had a question about, will there be multiple attempts per question in the test like homework? And that will be a no. You only get one attempt on the question, right? Because since that is the exam format, so only one attempt on the question and one attempt on the entire homework, entire test also. Musab asked, would that be the merged exam? Would that be too much for one class period? And I don't think so, because again, like I said, I'm not going to increase the number of questions. It probably will go down. If I were to do two tests separately, there would be, more questions. But if I combine the two, like I said, because in chapter 2, I will automatically be testing some concepts of chapter 1, you may actually see lesser questions from chapter 1 since they're already going to be used in chapter 2, right? So I wouldn't have to do like a separate question from chapter 1 because I know we're actually covering our bases in chapter 2 by presenting a new question. So that's the idea over there. So yeah, you wouldn't have too many questions. All right, Marquise, you said sounds good, Mickey. Okay, you're talking about less stress with that, okay? Yes, Anna, the questions will come from the same questions that you are seeing in homework. So the pool of questions is always going to be what you are seeing in the homework problems. But yeah, we're just going to have them, like I said, combined with chapter 1 and 2, and then again, keeping the numbers low enough that you can still do a 1-hour exam. I don't want the exam to go longer than our class period. Yes, Isaac Buckles asked, would the exam be in My Open Math? And yes, the exam would be hosted in My Open Math also. But we would be taking them on Zoom, just like we do our class sessions. You guys will still be logging into Zoom that day, and we will be on Zoom. Obviously, there'll be no lecturing that day. You will just come in. I will give you the password for the exam. You will go ahead, take your exam, and once you're done with the exam, you will be able to leave. So if you get done early, you can leave early. If you needed to stay 5 minutes extra or something to finish the exam, I would be okay with that also. I'll give you a little bit of a, what would we call it? A little bit of a bonus time, extra time, just to make sure you have enough time to finish the exam. So probably not too much, maybe 5-10 minutes kind of bonus time, because I know you have other classes and work and stuff to get back to. Gabriel, you asked if there will be a chapter, a practice. So yes, I will create a practice for chapter 2 assignments as well. Yes. So Phoenix, it will actually count as one single exam grade. So essentially what I will do is, and I'll make the change in your course syllabus. So instead of having 2 separate exam grades for chapter 1, chapter 2, they will just combine into one single exam grade. Yes, so Wyatt, you asked, will there be no notes? Can I use a pen paper calculator? Strongly recommended. Yes, pen paper calculator, so you can kind of work out, do your scratch work. And in terms of notes, we always allow you guys to use the unit circle. And then if you think any of those definitions for the trig functions will help you, you know how we have them defined in terms of the right triangle trigonometry or any of those formulas. I can give you guys a cheat sheet for that. And I probably already have that from a previous semester. So yeah, I can allow you formulas. Yeah, no, Alexandra, I think, or Mickey, in reality, I kind of think of, even if I had to go look at something, I'd probably go find a formula or a reference, right? So I kind of look at it like we use cheat sheets in our everyday life. So I'm going to let you guys have that for the exams as well. All right, guys, any other questions coming to mind? All right, if you do remember something, don't hesitate to ask me, but how about we get back into our section 1.4? We were kind of working on a question last time that we did not get to finish. So let's get back into that. And we're kind of almost at the end of section 1.4. Let's see how far we can get tonight. I'm really hoping we can do, wrap up chapter 1 here today. All right, my dears. So we were looking at try it now, number 2, and we were trying to figure out using the Pythagorean identity of sine square plus cosine square equal 1, how can we come up with this new Pythagorean identity of cotangent squared theta plus 1 is equal to cosecant square theta plus 1. So if you haven't had a chance to, finish those calculations from last class, I can give you guys a couple minutes to do that. But if you do have a process outlined as you were working on it, go ahead and share that individually with me through the chat so I can kind of see what you were working on or what you did to go from that one identity to the next one. So again, can I get this guy to work? There we go. Okay, so basically the idea is how can you use to go from here to here. Sorry. All right, very nice, Phoenix. So Phoenix, are you actually taking the cotangent and breaking that down? Because what you actually want to do is you want to start with the sine square, cosine square plus 1 is equal to 1, right? You want to actually start with that identity and see how can you modify that to convert it into cotangent squared plus 1 equals cosecant. So, and this is kind of what we had done last time, when they had asked us to look at this example 4 over here. So this is where they had asked us to, sorry, I'm looking at the wrong one. Oh, right here. So how they had taken this guy over here and rewritten it into the 1 plus tangent squared equals secant squared. That's kind of what I'm looking for, is how can we go about doing that? Oh, no, not a problem. All right, so to give you a hint, um, And Phoenix, you actually did kind of build up on that with the answer you sent me, because think about, what are the breakdown of cotangent and cosecant, right? And that will kind of tell you, okay, which, and Mav, you kind of just said that, yeah, you need to start out by actually dividing both sides of your equation by the sine square, because as we know, cosecant is the reciprocal function for sine, right? So if you actually did start out, yeah, Mav, very nice. So let me see, you've got, look at that, perfect. So yeah, start by dividing both sides of this, sorry, sine, not cosine, by sine squared theta. And then it's a matter of cleaning it up. Andrew, is that supposed to be like cosine plus 1? Is that supposed to be like in parentheses and then being divided? Or is it just the 1 being divided? Okay, I see that. And then are your functions supposed to be squares or just single functions? Single. Okay, so that then, in that case, that relationship would not work out. Because you can see how you have cotangent square and cosecant square in the question itself, right? So that actually tells you you will need to keep the functions in the square format. All right, guys, so what do we do now? Once you divide both sides by the sine square theta, what do we end up doing? And if you actually wanted to keep it in the order as the cotangent plus 1 equals cosecant square, you actually may want to switch the sine square and cosine square on the numerator. But again, associative property works either way, so it really wouldn't matter. But like I said, if you wanted to keep that. So, Mickey, no, we do not need to divide by cosine of theta, because this will actually clean up as it is. All right, let's take a look here, guys. So you have sine squared theta plus cosine squared theta on the top, right? So if we end up dividing, just kind of splitting that denominator, if we end up dividing both sine square and cosine square by the, sine squared theta that we just brought in, and then of course on the right-hand side, we have 1 divided by sine squared theta, you will see, of course, when sine and sine cancel each other out, this will just end up becoming 1 plus, what does cosine square over sine square change into? What is that defined as? Cosine square theta over sine square theta? Very nice, Wyatt. Very good. Exactly, because that is the reciprocal function for tangent. So cosine squared over sine squared. Yeah, very nice, Mickey. That will become your cotangent function. So this will then become, and of course, since they are both squares, this will also become cotangent squared theta. And then yeah, so Janice, you can actually rewrite 1 over sine square also, because remember 1 over sine square is the definition for the cosecant function, since they are reciprocals of each other, right? And you can see, like I said, you can use the associative property and rewrite this guy as cotangent squared theta plus 1 is equal to cosecant squared theta, and that is just what we were trying to do. So basically, if you have this relationship of sine square plus cosine square equals 1, you can see based on that, we are able to come up with 2 more trig identities. So those would be the three different Pythagorean trig identities that we are talking about in this course. All right, very nice, guys. Did anybody have any questions on this before we move forward to the next set? All righty, so let's take a look at couple more different examples over here. I'm gonna go ahead and clear this out. All righty, so let's take a look at this guy here. So you can see we're saying, okay, if tangent theta okay, Wyatt, thank you for letting me know. Not a problem. I appreciate that. All right, guys, tangent theta is equal to 2/7, and they're telling us theta falls into the third quadrant. Find the cosine of theta. So let's think about this. We're talking about, our unit circle here. We're saying tangent is 2/7, and your angle theta, falls somewhere over here in the third quadrant, not second. Third quadrant, which will be somewhere over here. And they want us to find cosine of theta. And this is kind of neat because I love that they are showing you two different ways of doing this. So let's take a look here. So for the first approach, we're saying, okay, so we know tangent is defined as y/x. And if your angle is in the third quadrant, we can basically imagine a triangle in the circle with some radius. So they're basically saying, okay, think about if you had a triangle, in that third quadrant, then basically if your tangent is defined as 2/7, and we know this is defined as y/x, but being in the third quadrant, right? Being in the third quadrant, we know both x and y values are going to be negative, and you can see that is where we are coming up with this definition that x could be -7, y could be -2. So that would give you the ordered pairs, -7, -2. But we also know two negatives make a positive, so your tangent value in the third quadrant is always going to be a positive number. So that's where you had the positive 2/7. But knowing that this angle falls into the third quadrant tells us that both x and y values should be negatives, right? Alrighty, so now they are saying once we come up with the x and y values, then you can use the Pythagorean theorem to basically find what the radius of this circle would be. And so basically, remember the basic Pythagorean is x squared plus y squared equals r squared, which we then translated into the equation of the circle, right? So x is 7, y is 2, or -7, -2. Go ahead, simplify that, and you will come up with the radius. Of course, we know 7 squared is going to be 49. -2 squared, of course, is going to be 4, which of course adds up to 53. And if that is equal to r squared, we will of course need to take the square root. So you will get plus or minus, and r will end up being a distance, right? Because it's the distance from the circumference to the center of the circle. So you know your radius is going to be a positive number. So you come up with radius of square root of 53. Now they want us to find the cosine function. So remember we define the cosine function as x divided by r. And so you will see our x value, of course, was -7. So you take -7 over r, which we just calculated as square root of 53. Now, remember, you are supposed to rationalize your denominator, so you should technically be multiplying both top and bottom by square root of 53, which would then end up giving us -7 square root of 53 divided by just the number 53. But yeah, so that's one way of doing it, right? Coming up with your x and y values, since we're given the tangent function, figuring out what the radius of the circle would be. And then based on that, we can find what our cosine function comes out to be. Now, the second approach that they are talking about is using that identity of tangent plus secant, and we know secant is the reciprocal function for our cosine function, right? So if you go ahead and use this Pythagorean identity, well, we know our tangent is 2/7, that's given to us. We will go ahead and simplify the 1 plus tangent squared. So of course, again, 2 squared is 4, 7 squared is 49. Then you find your common denominator, so we would multiply this guy by 49, which would end up giving us 49 plus 4 over that common denominator of 49. And you can see this is where that 53/49 came from. And then same thing, since you have a secant square, you would end up taking a square root on both sides, right? To cancel out the secant square, which would again end up giving us positive or negative square root of 53/7. Go ahead and clean that up. Now, again, we know our angle is in the third quadrant, which tells us our cosine value will be negative. Therefore, your secant is also going to be negative. So that means go ahead and discard the positive answer, and we're just going to keep the negative result and then use that reciprocal idea. So since we know secant is 1/cosine, and you're trying to find the cosine function, go ahead and flip that fraction, rationalize your denominator, and you're going to come up with your answer. So, whichever method you think works perfectly, or whichever one you think is going to be more straightforward. And sometimes it may depend on what information we are given, right? Are we able to use an identity or not? So based on that, you can see, is approach 1 going to work better, or approach 2 going to work better? So let's look at an example of trying to figure this out on our own. So let's go ahead and clear this guy out. And we will look at secant phi, or phi, whatever you want to call it, is equal to -7/3. Your phi angle is between pi halves and pi, and they're asking us to find tangent and sine of theta. So just by looking at the information here, can you tell me what quadrant are we looking at when we're talking about the angle being between pi halves and pi? Quadrant 1, 2, 3, or 4. Which quadrant is this angle phi going to fall into? Very nice, Mav. Yeah, perfect. Oh, I'm kind of getting mixed answers here. So far I've had quadrant 1, 2, and 3. Majority of the answers is quadrant 2, though. All right, so remember, guys, we're talking radians here. So this is going to be 0. Pi is always for 180 degrees. So pi is going to be here, which actually tells us pi halves is going to be at the 90-degree angle. So that actually does tell us that this is going to be quadrant 2. Okay. If it was between 0 and pi halves, it's quadrant 1. If it is between, what do you think this angle will be here? Across from the 90-degree in terms of radians. So 2 pi actually brings us all the way back to 0, because 2 pi is actually 360 degrees. So yeah, Kara, very nice. You would be at 3 pi halves, which is what, 270 degrees? Alrighty, guys. And again, like I said, as you use the unit circle more and more, you will start remembering these angles, their positions a little bit better. All right, guys. So we know our angle falls in quadrant 2, which quadrant 2 should tell you your x value is going to be negative and your y value is going to be positive. So x is going to be negative, y is going to be positive. So can you tell me, what approach do you want to use? Do you want to find the radius of the circle? Do you want to use the identity between the secant and the tangent function like they basically did here? You know, using that 1 plus tangent square equals secant square. Do you want to use that identity to figure out, you know, what the tangent function is, since they are actually asking us to find tangent? So pick your method. Do you want to find the radius of the circle? Do you want to use the identity? And then once you're ready to share your answers with me, go ahead and share them with chat. I'm going to give you guys a couple minutes to work through the math. Okay, looks like I already am seeing an answer come through. Oh, Mark, are you able to leave your answers in fractions? All right, so I've got answers so far from Andrew, Mark, Braden, Isaac Buckles. And honestly, guys, I have not solved this one out. So I don't know if your answers are correct or not, but we'll figure it out once I get a chance. You know, everybody has a chance to go through the math. So I am seeing definitely some overlap in answers. So my assumption would be, you know, well, either all of you did it correctly or all of you are wrong. We're coming up with the same answer. Mickey, was that for the tangent or the sine function? Okay, tangent, okay. Okay, all righty, guys. If you have your answer coming through, go ahead and put it on chat. All right, Lolly, I see yours. All right, Mickey, I see yours. Okay, so let's take a look here. Okay, Isaac Luhan, I see your answer for the tangent function. All righty. All right, guys. So I think since they're giving us the secant function, I would like to use the identity. All right, Cameron, I see yours for tangent, Jeff for tangent and sine. Okay, so I am actually seeing variations. So some of you have like the correct numerator or similar numerator, different denominator. Some of you, of course, have matching answers. So let's see what the function definitions are over here. All right, Phoenix, I see yours. All right, so our trig identity, again, the Pythagorean identity, I'm going to start out with the same one here. 1 plus tangent square is equal to secant square. Okay. All righty. So 1 plus tangent square, and I guess we're using phi, is equal to secant square. Now you can do this by plugging in the numbers, or you can do this at this stage. So since we're actually trying to find what the tangent function is, I'm actually going to go ahead and move our 1 to the other side and rewrite this guy as tangent squared phi is equal to secant squared phi minus 1, right? So that we can isolate the tangent and then have this guy on the other side. All right, so of course you can see our secant is going to be negative 7 over 3. And of course we need to square that, minus 1. And as you can imagine, that will, the negative times negative will become positive. 7 times 7 is 49. Of course, 3 times 3 is 9. And then find your common denominator to subtract that 1, which of course will end up becoming 49 minus 9 on the top, and then a common denominator of 9. So looks like this guy will end up becoming 40 over 9. And remember, this is for the tangent squared phi, which means when you're trying to find the tangent function, we will need to use square root, right? So we take a square root on both sides, which will end up giving us positive and negative. Now, the square and the square root will cancel out, leaving us with just the tangent of phi function. And then this is where I saw your multiple answers right. Now, can we simplify square root of 40 when you take a square root? 40 itself is not a perfect square, right? So we will need to break it down. So with the 40, yeah, very nice, Wyatt. That's exactly what I was looking for. 40 can be broken down into 4 times 10. Now, 10 is 2 times 5, so we cannot break him anymore. But when you end up taking a square root, well, square root of 4 is 2, but then we can leave square root of 10 as is, right? So this will become 2 on the outside, square root of 10 on the inside, and then, of course, our denominator was 9. Now, guys, since we know this angle falls into quadrant 2, which, as I suggested, that means x will be a negative number, y will be a positive number. What sign should the tangent function have? Will tangent be a positive number or a negative number? Well, think about this. Okay, so remember, tangent is defined as y over x. Mav, Wyatt, very nice. Yeah. So it is going to be a ratio of both positive and negative numbers in there, guys, because we know y is going to be positive, but x is going to be negative. So your tangent is actually going to be a negative number. So you should have negative 2 times square root of 10 over 9. And several of you had that answer in there. So good job, guys. Oh, sorry, 3, not 9. What am I doing? I just did the numerator. I didn't take a square root on the denominator. My apologies. I'm glad I caught that before, we moved any further. So yeah, sorry, you were taking square root of 40 on the top, square root of 9 on the bottom. So we just did the top here. But yeah, square root of 9 on the bottom will become 3. I'm so sorry I didn't catch that before. So yeah, sorry, it should be tangent of phi is going to be negative 2 times square root of 10 over 3. Questions on this before we move forward to finding the sine function? And as we went through the math, did you guys see where you potentially might have gone wrong because some of you did not have that same answer? Yeah. Not seeing any questions come up on chat though. Alrighty, let's save this screen because I'll need to erase this so that we can get into the sine function here. So let's take a look at how would we calculate the sine. So I do apologize, guys. I will need to erase this part out so that we can create space. But I did save the screen and I'll post it on D2L for you guys to go over if you needed that. All right, so let's come back to our problem here. And then let's take a look at the sine now. So remember, secant is defined as the reciprocal function of cosine, right? So that means if you have secant defined as -7/3, well, then if you wanted to find the cosine function, we would basically just flip the fraction over, right? So your cosine would then become -3/7. Now, why are we going to the cosine function? Because we can use another identity over here, because now we can say cosine square, well, we'll keep with the phi. Cosine squared plus sine squared is equal to 1, right? So if you wanted to find the sine squared function here, we can basically go ahead and subtract our cosine squared, move it to the other side, and get sine squared by itself. So your rewritten identity would be sine squared phi is equal to 1 minus cosine squared phi, right? And then you can go ahead and find that function that way. So let's see, we would have 1 minus, we just came up with the cosine as -3/7. So that would become -3/7 squared. And so that tells me we will end up with 1 minus, again, negative times negative will become positive. 3 times 3 is 9, 7 times 7 is 49. Same thing, find your common denominator. And we would end up with 49 minus 9 over 49, which of course then leads us to 40 over 49. So this will be for sine squared of 5. So last step is, of course, taking the square root on both sides, right? So when you end up taking square root on both sides, why there is not a similar identity between secant and cosecant. So in terms of the Pythagorean identities, we only have the relationship between the tangent and the secant that we just use for, finding the tangent function, or the cotangent with cosecant. So yeah, nothing directly between secant and cosecant. All right, guys, so to get the sine by itself, we'll go ahead and take a square root on both sides. So again, the sine squared and the square root cancel each other out. So we are then left with sine of phi is equal to, let's see, square root of 40. We just did that. So we know that guy simplifies into 2 square root of 10. And then square root of 49, of course, since that guy comes from 7, we know he's going to be square root of 49 comes out to be 7. Same question, guys. Since we are in quadrant 2, what will be the sign on the secant function? Is it a positive number or a negative number? Will the sine function be positive or negative? All right, Mickey, I see your answer. Jeff, I see yours. All right. Cameron. Braden. Okay, so again, you guys are giving me both answers. One of you were saying positive, the other one is saying negative. So let's think about this again. Remember the y represents the sine, right? Because we do y over x, sorry, y over r to find the sine function. So remember, sine is defined as y over r. So remember what we said, your y is going to be a positive number, and then radius, of course, being a distance, is always going to be positive. So your sine function is actually going to be a positive value. Yes, Mickey, it does take a little while getting used to secant and sine and cosecant and cosine, because initially we do tend to kind of mix those functions up together. So trust me, it's a beginner's mistake, but you will get more comfortable, right, as you start using these functions more and more. Yeah, Braden, exactly. It should be positive. So again, guys, take a little bit of time. You know, it's okay to get the answers incorrect at the beginning because we're still learning all of it. But once you get comfortable, where the angle falls is going to be crucial, right? Because the math can tell us it can be both positive or negative, but then based on its position, we need to pick one answer, right? All right. Did anybody have questions on this before, again, we move forward to the next part? Alrighty, no questions. Not seeing anything come through on chat. So you can kind of see what were the different functions we talked about in here, and then they do kind of nice clean up on that. I would like to pick just a couple examples here, or maybe one example, because I do want to get into section 1 point. So we did prove the identities last time. Mm-hmm. I don't know, I guess we'll do number 13 over here. And you can see this one is actually asking us to figure out all the remaining functions over here. So let's look at number 13. And I'm going to try and move it up a little so I can kind of get this blank space over here to work with. Alrighty, so you can see they're giving us the tangent function. They're giving us the quadrant. What quadrant is this, guys, between 0 and pi halves? Andrew, very nice. Yes, this guy is going to be quadrant 1. Musab, Kara, very good, guys. So yes, this guy is quadrant 1. So remember, quadrant 1, and again, just our rough sketch over here is this quadrant we're talking about. So this actually tells you your x and y are both going to be positive numbers. So if tangent is given as 12 over 5, how do we go about finding sine and cosine? We'll come with the other three later on. What is the general definition of the tangent function? How do we define it? In terms of, you know, that first quadrant. Very nice, very nice. Yes, so Mickey, you had y over x. Cameron and Mickey, you also gave me sine over cosine, opposite over adjacent. Look at that. I am so impressed. Very good. Yeah. So I was actually looking for the y over x definition particularly here, because we will actually need to find the radius of this circle, because we do need the r value, right, to find the sine and cosine function. So we're actually falling back on these definitions here. Sine is y over r. Cosine is x over r, right? And then we can use the reciprocal functions on that. So yeah, let's figure out what your radius is. And Andrew, I did see that answer. So it looks like you already have your radius calculated. Very nice. But I do want to give your classmates a minute to come up with that radius. So again, guys, remember, if your tangent is defined as y over x and our fraction is 12 over 5, and we know being in quadrant 1, both x and y have to be positive numbers, then we know 5 is going to be positive, 12 is going to be positive. So that actually tells us our x value is 5, positive 5. Our y value is positive 12. And based on that, you should be able to calculate your radius. So can you just share the radius value with me? What will your radius come out to be once it's simplified? Jeff, very nice. Cameron, Mav, Joshua, very good, guys. So yeah, 5 squared is 25. Cara, Logan, look at that. You guys are doing amazing here. So what does that add up to? 169? Yep. And then, of course, when you take the square root of 169, that comes out to be 13. Look at that. Great job, guys. Perfect. So impressive. And remember, again, the radius is a distance. So it's always going to be a positive number. So we are basically discarding the negative root here. All right, very nice. So now that we have our radius, we should be able to calculate our remaining 5 functions. So your sine of theta, is going to be what? Cosine of theta is going to be what? And then we'll come back and do secant, cosecant, and then, well, you can actually do cotangent since we already know what the tangent function is. You don't really need the r value for the cotangent function. So Mickey, which one was sine and which one was cosine? All right, Cameron, I see your answer in there. All right, Mickey, very good. Wyatt, I see your answer in there. Janice. Alrighty, guys, so if we're defining sine as y over r, then like I said, y is going to be the numerator value in the tangent function, so that's your 12. And then, of course, our radius just came out to be 13. So very nice, those of you who shared that with me. And then, of course, x is the denominator of the tangent function, so that's going to be the 5. Yeah, very nice, guys. And then again, same thing, radius for the denominator on the cosine function. So yeah, 12 over 13 for sine, 5 over 13 for cosine. So can you now tell me what the remaining 3 functions will be? Why did you have it backwards? Let me go back and look at your answer. Yes, you did have the sine and the cosine reversed. Yeah. All right. So what is our secant, cosecant, and cotangent functions going to be here, guys? All right, let's see. Cameron, you have cosecant, secant, and cotangent. Okay, Jeff, cosecant, secant, and cotangent. Very nice. Musab, I see your secant. So remember, secant is the reciprocal of the cosine function. So this guy actually is defined as r over x. Cosecant is the reciprocal. Musab, I see the second function there. Mickey, I see yours. Okay. Cosecant is the reciprocal for the sine function. So this is going to be r over y. And then cotangent, of course, is the reciprocal of the tangent function. So he becomes x over y. No, Isaac, remember, because the cosine function is divided by the radius, so your denominator is going to be the r value. Because if you're just inverting 12 over 5 for the tangent function, remember that is your cotangent function. So cotangent will be 5 over 12. And then like you guys had, your cosecant is going to be 13 over 12. And of course, the secant is going to be 13 over 5. Yeah, very nice, guys. All righty, very good. Did anybody have questions on this example here? And you know, the best part is, since you were in quadrant 1, right? We didn't have to worry about positives or negatives because we know both x and y values are positive, which means all the functions are going to have a positive value. But as soon as you go to quadrant 2, quadrant 3, quadrant 4, signs are going to be of importance, right? Because that's where either x or y then ends up becoming negative or positive, or both of them are negative. So please be careful about your quadrants in there. All right, let's save this screen. And again, you can see there's a bunch of examples here. If you need, you know, extra practice out of your My Open Math. All right, perfect. Let's move on to section 1.5, or as your textbook calls it, 5.5. So kind of bringing everything that you have done so far at this point. So, you know, of course, we started out by defining our sine and cosine functions as ratios, right, of the side of a triangle. And you can kind of see that image right over here. And we've just kind of built up on that. So we're coming back to this idea of triangles and then get into some applications of how you can use this definition to actually solve some, you know, real world problems. So back to our definitions for sine and cosine over here. So y over r, x over r for sine and cosine respectively. And I've already talked about this, but this is kind of where your textbook formally brings in this definition. So if you have a right triangle, with an angle of theta. So you can see we're defining this guy as angle of theta. So with respect to this angle, this becomes the opposite side. This is the side next to it, right? So this becomes the adjacent side. And then always across from the 90-degree angle, across from the 90-degree angle is the longest side of the triangle, which of course is what we call as the hypotenuse. So when you are defining your sine, cosine, and tangent functions based on the sides of the triangle. And like I said, I've already talked about this. Your sine is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. And tangent, of course, being a ratio between sine and cosine, is defined as opposite over adjacent. And you can see they're talking about that mnemonic here also, SOHCAHTOA. So if you remember that with the right triangle trigonometry, then you know you already have your function definitions with you, right? Which remember in our x, y, and r terms, this of course then becomes the r. The opposite side is the y. The adjacent side is the x. So that's kind of how they would translate with each other, right? So the sine becomes y over r. Cosine is x over r, and then of course your tangent function becomes y over x. So you can kind of see how that overlap happens over here. All right, so let's put this to use. So what they're actually saying, and I'll come back to that example just to go over it very quickly, but you're basically saying when working with general right triangles, the same rules apply regardless of the orientation, right? So your triangle doesn't always have to be in this form. It can look something like this, but those properties are still going to hold as long as it's a 90-degree triangle. These function definitions are still going to stay the same. So it doesn't matter how your triangle is situated, it's still going to work out in that case. And so take a look at this example here. They're asking us to find the value of cosine of alpha. So since this is the angle over here, that makes this again the opposite side. This is the adjacent side. And then of course, this would be the hypotenuse. So we know cosine is ka, right? CAH. So that's adjacent over hypotenuse. Your adjacent side is 15. Hypotenuse is 17, so that becomes a ratio of 15 over 17. Just as a reminder, you are working with fractions here. And remember, the basic rule about fractions is always reduce your fractions. So even if it doesn't say that in your instructions, by default, you are always reducing that fraction, okay? So just please keep that in mind. All right, so you can see how they are taking this, well, I'm going to call it crooked, the crooked looking triangle, and still defining our functions over here, right? So you will see if this is angle alpha, in terms of angle alpha, this guy is the opposite side. This is the, sorry, wrong. Because that's the hypotenuse. That's across from the 90-degree angle. So that's the hypotenuse. Sorry, opposite, and this guy becomes the adjacent, right? So with angle alpha, you will see we are saying the adjacent side is going to be the 3, and the hypotenuse, of course, is going to be 5. With the sine of angle alpha, you will see the opposite side was the 4, and then your hypotenuse, of course, is still the same. Now, if you change the angle and you're looking at beta over here, well, for angle beta, this guy now becomes the opposite side and this guy becomes the adjacent. Hypotenuse, of course, will still stay the same. And so now in terms of angle beta, your cosine function is going to be 4, which is the adjacent side over the hypotenuse. And you will see sine of beta is going to be the opposite, which is 3 over the hypotenuse 5. You should also notice how these two have the same function value and these two have the same function value. And we'll talk about that here in a minute. But you can see, right, how that changes based on which angle you are looking at, and then which is the opposite side and which is the adjacent side. So the placement of the angle is going to be important here. But it's still the same definition. Opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and tangent, of course, is going to be opposite over adjacent. That will stay the same, doesn't matter which angle you are looking at. All right, let's do this. Try it now. And let's move him a little bit higher. All right, so a right triangle is drawn with an angle alpha opposite a side with a length of 33, angle beta opposite a side with length 56 and a hypotenuse of 65. And they want us to, of course, find the sine and cosine angles for both of them, or functions for both the angles. All right, so this is our 90-degree angle here. You can call this alpha. Call this beta. So in terms of angle alpha, they are saying the opposite side is a length of 33. Angle beta, opposite side with length of 56. And hypotenuse, which is of course across from the 90-degree angle, has a length of 65. And if the orientation of your angle, triangle is different from mine, it's not going to change that. Okay, so sine of angle alpha, cosine of angle alpha, and then sine of angle beta, cosine of angle beta. So go ahead and share all 4 angles with me, and you can just use A and B for alpha and Beta, if you don't want to write out the whole word, so you can just say sine A, sine B, cosine A, cosine B, and that would be fine. Andrew, that works too. All right, very nice. All right, so let's check that. You are doing sine of alpha, cosine of alpha, okay. Sine with beta, cosine with beta. Okay, very good. Janice, I see your answer in there. Now, were we not able to reduce these numbers here, guys? Did we try to see if these numbers can be reduced or not? $65 is what? 11, so that would not go into 33, would it? They cannot be reduced. Okay, Mickey says they cannot be reduced. All right, so I am seeing, I missed somebody here, didn't I? So I've got Andrew, Janice, Jeff, Mickey, Musab, Isaac Buckles, Phoenix, Logan, Musab with your second answer. Alrighty, let's take a look here very quickly, guys. So sine of alpha, since this is our angle alpha over here. All right, Isaac Luhan, I see your answers coming in. Oops. Didn't mean to do that. Alrighty, so since this is angle alpha over here, your opposite side is going to be 33. Of course, the hypotenuse will be the same for both angles, will be over 65. All right, Cameron, I see your answers coming in. For angle alpha, of course, your adjacent side is the side next to it. So that would be 56 over 65. All right, Isaac, very good. And then let's move on to beta. So for beta, of course, this is the angle with beta. So that means this guy now becomes the opposite side. So that is going to be 56 over hypotenuse 65. And then, of course, your adjacent side for beta is going to be 33 over 65. And again, you should notice, like we did before, how cosine of alpha has the same value as sine of beta, and sine of alpha has the same value as cosine of beta, which of course you guys saw that as you were putting your answers in. Questions on this one, guys? Alrighty, so basically let's take a look at this little paragraph over here. So they're basically saying how, we noticed that cosine of alpha and sine of beta had the same values. Cosine of beta with sine of alpha had the same values. And they're basically saying this makes sense since the side opposite alpha is basically the same side which is adjacent to beta, right? And we're basically saying since the three angles in a triangle need to add up to pi or 180 degrees, which we know is true from geometry, so we're basically saying your other two angles, since one of them is always going to be a 90-degree angle in the right triangle, we know the other two angles have to add up to 90 degrees or pi halves. So basically what that translates to is that the value of angle beta is going to be 90 degrees or pi halves minus alpha, or vice versa, right? Alpha is going to be 90 degrees or pi halves minus beta. So that actually tells you that this relationship here can also be rewritten as this relationship over here. And guys, this is actually another one of those identities that actually work out for sine and cosine functions. So you will see how they are taking this idea that we just saw and creating two new identities over here. So you have cosine of theta is going to be sine of pi halves minus theta. So, that's where we were bringing the alpha beta, right? But just in general terms, that's 90 degrees minus the original angle. Same thing with sine theta equals cosine pi halves minus theta. So if you can, again, this would be another one of those functions that I would keep handy as you are going through different values over here, different examples. So these are called the cofunction identities. Okay. Now let's get into okay, so they're kind of talking about just a little snippet over here that, if you know all three sides of the triangle, then of course we can come up with our sine and cosine functions. Now they're saying with the right triangle trigonometry, we can start looking at triangles in which an angle is known, but we don't know all sides of the triangle. So that is what this little example is looking at next here. And I guess that actually brings us right at 11, doesn't it? Yeah, so I guess we'll pick it up from here. We're actually, again, not too far away from getting done with this section. So let's wrap up section 1.5 on Wednesday, and we will actually get into chapter 2 since we did talk about combining chapter 1 and 2 exams together. So let's finish section 1.5 on Wednesday. We'll get into chapter 2, and then I will potentially give you a tentative new date for chapter 2 exam, so you can at least start kind of preparing for it. Yes. If you have any questions, please stay back and I'll be happy to answer any questions. And if not, have a great day, guys, and I will see you on Wednesday morning. Be safe, everyone. Take care. Bye-bye. Bye, guys. All right, Wyatt.
Hello?
Hey,
Hear
Isaac.
me? You hear me?
Yes.
Okay. So when because I need to do like a tutoring session because I missed the